All right, everybody, welcome to another Product Spotlight. My name is Dave Cooper, and we are coming to you live from California. And today we have a great show like we do pretty much every other show, in my opinion. So what's great about today's show is we're going to talk about something that has been around for quite some time, but a lot of people have not seen us. So join us today for this unique Product Spotlight with Daniel Esparza. We're designing, engineering, constructing a building from the bottom up gets turned upside down. How does TGE bring together construction, manufacturing, sustainability, design with a construction delivery system? Here is what we're going to learn today. How can you engineer and build a safe, sustainable, lighter structure, eliminate the tower crane? Oh, that's right. Multi-story buildings eliminate the tower crane, improve safety and quality, and address the elements that plague the mid-high-rise market like cost, scheduling, and sustainability. Dan Esparza, principal member of TGE Construction, LLC, with partners Dr. Charles H. Thornton and Jeff Grillo, building top-down innovation for the construction industry. Now, with that said, at Dave Cooper Live, we are bringing you the people and the processes that are building it better. Our guests and topics include experts in building systems to building science, building codes, and the tech used to build it better. We are always seeking out the best and the brightest in construction and discovering all of the ways that innovative buildings come to life. Now, we cannot do this without our sponsors. So a big shout out to Ben Hershey and Joe Butler from Forward Solutions Group. They are a team with more than 175 years of experience developing and specifying manufacturing for panelized, volumetric, modular industries with best practices in development and implementation. They offer consulting with investors, developers, manufacturers, and builders in using off-site manufacturing methods. Forward Solutions is driving companies to succeed where others have failed. Please reach out to Ben at forwardsolutionsgroup.com. And also a big thank you to our other sponsor, Howick. Howick is a pioneer in the technology of precision light steel roll forming machines. For over 40 years, their commitment to innovation in cold form steel, also known as light gauge steel, precision manufacturing, uncompromising quality, and exemplary customer service have defined the Howick way. Their commitment underpins the competitive advantage enjoyed by their customers. To learn more, please visit their website, howickltd.com. All right, everybody. So without further ado, let's hop into the show today and bring Dan Esparza on with us. Dan, how are you today, sir?
Great. How are you?
Man, I'm doing wonderful. Thank you. This is going to be an exciting conversation because one of the things that I've learned that I thought I knew everything and I didn't know everything about, how you're building and the technique you're using. You're doing mid to high rise buildings and you're literally building from the roof of the building down, not the other way up. So the precision, the accuracy, the offsite components you guys are using has to be spot on.
Yeah.
Before we get into that, though, we want to know everything about you, Dan. Everything from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we will call your mother. You got 2 minutes to do it, so hop right in.
There you go. Well, I appreciate that. Dave. And it's great to be on your program. You've got a lot of great shows and great content. I was watching your tour of the Integra facility, and that's really great stuff. We're always looking to push the innovation bar and where people are doing things differently. We're very excited about and like to be part of that story. But a little bit about me. I've been in the construction space my entire career. My father was a builder, actually an architect, and started a family business, and so I kind of grew up in it, and so I've done it for my whole life. Got out of college and went straight into the industry and started my own construction company, probably a little too early, but started a company at 26. Really enjoyed it. It's really baptism by fire, but built a company and then from there a succession of executive and leadership roles in larger firms to grow their businesses. And so in the last 10 years was in the Alaska Native space, and here within the last five or six, it's been the evolution of top down and building in this tall building space sector, which has been incredibly exciting. The relationships that we have across the industry are continue to grow literally on a daily basis, and so it's the innovation model really sticks, and so exciting to be part of it. Really, the whole process of bringing top down to market is really an evolution of Charlie Thornton, which I'll talk about here in a bit. But yeah, it's exciting to tell the story.
It is exciting, and this technology has been around since the 70s. Yes.
Yeah, actually, Charlie started the operation. Our first couple buildings were constructed through the kind of the lineage and the history of this process. The building structural design, the delivery, the building process, and the integration of the delivery vertical supply chain. First buildings were built in the 70s, predominantly in the Bay Area. We got 5 buildings in that market through 72 through 77. And then 2 on the East Coast, hospitality structure, West Virginia, and then we had one in New York, the Russian Mission. And so that evolution is through the 1970s. But yeah, it's been a 50-year technology process and continuing the best engineering services for it. But yeah, it's been around a while, and we're continuing to develop a supply chain. That's probably been the most important part of the piece to where we're at today in 2021.
For sure. Well, listen, everybody, we are live on LinkedIn, YouTube, Facebook, and Twitch. Dan, why are we live on Twitch?
That's where all the young folks are at.
Yes. Yeah, you've been watching the show. That's where the young folks are. Even Greg Ugaldi, who's the head of the National Association of Home Builder, joins us from the Twitch channel. He is making even younger and younger. So we appreciate it. It's
really amazing, that generation and where they're at with the platforms and the space and the technology and right. Getting it out there on all the platforms, I think, is an incredible asset. And it's great to see you're forward thinking in that regard.
Yeah, we have to go where they're at because they're not coming to us in this industry. So, there's a lot of innovation happening in the industry, like it's happening with your industry. Why don't we give everybody an idea what this is? I have the video queued up, so why don't I open that? And we don't have sound to it, so maybe you can walk us through what's going on.
Kind of start to kind of walk through the process and what we do that's different than conventional construction. In the tall building space. The top-down delivery method is kind of an evolution from what was originally the IED system in the 1970s. And then correspondingly lift, and now what we have is top-down technology. And it is that an evolution of not just materials efficiency, supply chain management, but delivery to market in terms of the process. But if you want to run the simulation, we can do.
Yeah, let's do it.
Give you an idea of how it's built. And what this represents is a single core tower. It's not representative of all the type of structures that we provide. What's really, I think, unique about our build is that it's the efficiency of the structure, the efficiency of design, and how that relates to not just conventional construction methodology and techniques, but how we can create a more sustainable building. So when I say this is a standard kind of outline, this is a representative analysis of a single core tower. Some of our buildings are double core, triple core, so multi-core structures. But just for the purpose of illustration, we have this model to kind of give you, to give the viewer an understanding of flow, process, and how it goes together. What you're seeing on the right,
yeah. So on the right's conventional construction. I think you were just getting ready to say that. So sorry.
Yeah.
But on the left, the difference here, and I think because we get a lot of new people watching that may not understand the core. The core is the concrete core of the building that houses the elevator shaft, the mechanical lines, plumbing, all of that. So you build this central core, which makes it very efficient to do your mechanical systems and do all your runs. Correct. Right? Is that what we're talking about here?
Yeah, I mean,
and then you start.
Yeah, the core is is the structural backbone of the building, and this is where the sustainability and the efficiency of the building comes from, is the relationship of the deck plate and each floor and its interaction with the core being the structure itself in terms of its structural performance. But each one of those deck plates is in cantilever. So it's in compression and shear on the core. And so what we're able to do is better utilize the material, because concrete obviously performs better in a compression state than obviously tension. But the building on the right is the way we've always constructed buildings historically through, from high rise to mid rise construction. And what you're seeing there is a post tension cast in place concrete structure. Now, whether that's steel or this, this residential model that we're depicting, is you see how if this building is in tension and it's being built one floor at a time, you go up utilizing a tower crane, utilizing that traditional stepped approach. The phasing, right, the schedule, the sequencing, a lot of issues and problems with that. Just because that's just the normal way that's done. We're going to kind of go into the efficiency of that, which we have numerous studies on. But the building that we do and what our system is based on is the structural performance of the core. So we slip form the entire core, which you saw at the beginning of the simulation. And at the top, there are strand jacks that are put on the top of the core. And so basically what we've created is a work deck platform at grade. So if you can show it again, which creates a more uniform building process. And so from that grade level construction, all workers are working at grade on the ground and building a deck plate on a more manufactured basis. And then the strand jacks lift that deck plate into place and lock it into the core. And so lies the compression and shear into the core. What that does do, though, is it eliminates all of the columns in the building. And so, from a materiality perspective, we can reduce concrete by, 30%. In some cases, steel 20%. And so when you take just a conventional building that weighs, X pound per square feet, our building is probably half that, or, just in terms of the pounds per square feet and right, overall building weight. So there's some huge advantages there. Also from a sustainability model, if you look at core and shell, your embodied carbon represents 49% of embodied carbon if it's a concrete structure. But if we're able to extract those columns, extract that quantity, still have a high performing, high quality built building, which it is, and it's in cantilever and compression in the core, your embodied carbon content's probably reduced anywhere from 45 to 50% on right, core and shell. And so those are some significant improvements. But where the real, kind of rubber hits the road is the time to build it, the predictability of cost, the reduction of cost, and your sustainability profile. So a lot of advantages to the owners and where the market's going.
So if we look at this, we're looking at 490 days to completion versus 740 days to completion. I mean, that's almost a year difference, right?
Yeah, I mean, typically the projects run about 30% on average, with a betterment to schedule in terms of on-site construction. And all of those things can be measured in terms of the productivity, workflow, cycle time of the deck operation, the fact that you are working at grade, eliminating some of the non-value added time that is built into going vertical, specifically right, a tower crane. Tower crane typically works from a materiality perspective about 40%, 43% on average of time. So you put those kind of numbers together with labor on the efficiency of going vertical every 10 levels, working at grade and repeating that deck construction process is a significant improvement to sequencing of flow.
Yeah, it sure is. And the video we showed was an example, a rendering, but I mean, this is actually happening. I want to show one of the other videos from your site. Can I put it up there?
Yeah, no, absolutely. Whichever one you point up, I can kind of walk through it.
Yep. Let's add this one here. I mean, this really gives people a good understanding that, I mean, this isn't a concept. This is actually, happening at the moment. Let's see if I can get the volume off here.
Yeah, so this one is, so the one in the background, which is, if you can see that one, that's SRR3. That was the first building we did for this client. This was an international build. This is a computer, I should say a commercial tech campus. One of the background was built. The program on this one was about 3 years, 36 months for 200 million on the build. And so, as I mentioned to you before, in the, kind of looking at the depicting of the simulation, this is obviously a multi-core structure as opposed to what you saw in the simulation model. This is a 10-story structure. It's about 624,000 square feet. Again, it's commercial tech lab office. And there was no sub-level of parking on this. Most of our designs do have sub-grade parking, and we go through how that works in terms of a sequencing methodology. But basically what you're seeing here is the building process of a slip erecting the cores. So the core, where all that vital infrastructure that you mentioned is established in the core. This is your structural element. I think if you can pause this real quick, one comment that I did want to make was the foundations here are only underneath the core. So they're not underneath the entire footprint of the building, which is a huge advantage to cost and time as it relates to coming out of the ground. Because the only loads that are going into the structure are compressed into the core, and there's no net uplift. And so whether it's shred footings or deep piers or deep foundations, that element is limited to only underneath that one core structure, not the entire footprint of the building. So, if you're a builder, a developer, or whatever, you're looking at a space where you're trying to, reduce costs. There's about 30% on footings and foundations and structure X. Again, if you're not looking at a subgrade element to the project and it's just built on grade like this one is, a lot of variations, a lot of unique abilities to change the way that we construct and design buildings. So anyway, if you want to keep running it, this is the actual performance of this project. This was delivered in 14 months as opposed to the 3-year analysis. From start to finish. But what you're seeing here is a time elapse of what we do in terms of sequencing trade flow, right? And so what you're literally looking at is your deck erection, your roof. That's the roof being lifted with the strand jacks. The roof is locked into place. It's putting compression and shear on the core. And then the penthouse is now being constructed. And so what happens is the penthouse is completely built. It's a structural element. Any modular units are loaded onto that deck. And then with a very predictable cycle time. And then that just-in-time delivery process is integrated into how we cycle the flow. So that deck is then locked into the core through our design process. And each exterior element is, just like a connect. So the top of the curtain wall, which is the proprietary design to what we do in our system with our facade groups, locks into to the deck below it. So for watertight connection and air building envelope and air barrier tests.
So the cladding's already on this. What about the interior walls and mechanicals? Is that already done as well?
Yeah, so there's an intermediate lift where the build goes off about at grade about 5 feet off the ground, so workers are still not working at height. And rough-in MEP goes on underneath, so we can efficiently track that from all of the mechanical systems, fireproofing steel, putting in the fire suppression systems. Then the deck goes back down. We floor load the deck with final fit out. So anything that's going to be built on the floor. One of my partners likes to say that if there's a coffee pot that's going to go on the floor, it gets loaded on the floor.
Yeah.
So we're not moving materials up any service elevators or anything else. And then a concurrent task to that is installing the exterior skin, and then it goes up on a predictable lift schedule.
I mean, to me, this is absolutely amazing, and it makes all the sense in the world, right? You get rid of the big tower cranes. There's a lot more worker safety in place, so hopefully it helps your insurance and your risk when you're dealing with that, because for buildings like this, that's a high number, and the liabilities there.
No, absolutely. Yeah. And that's one of the things that we've spent a good deal of time on with our delivery model and supply chain is the insurable risk portion, the risk management piece. Obviously, this was an international build, but as we build in North America, different OSHA requirements and all the other things that go with it. All of it's compliant, its means and methods, but this is a structural delivery process. But one of our partners is actually Aon, and we've been promoted within their group and work with them pretty aggressively. And they've recognized that we actually have now reduced 4 significant insurable risks on construction sites. So, elimination of the tower crane, which is a huge risk and cost. Productivity. So time to construction on site is reduced. Worker health and safety, quality control. So there's some significant advantages, even on the OSIP side. So for owner-controlled insurance programs that really help, I think, in modeling how this project gets built. Risk mitigation is a big factor in the model.
Yeah, I would imagine so. Let's go to a couple comments here, and let's say hi to a couple people here. So we have Steve Alderman from CPA. Good afternoon from Dallas, Texas. Thanks for joining us. Ooh, Nikki Kruger's in the house. Hey, Nikki, how are you? It's good to see you from Annandale, Virginia. Nikki's doing some great things with mechanicals and HVAC stuff in our trades. So that is great. Andrew Sealy is joining from Hill Country, offsite grid. His job site is offsite. He's building everything using solar power on a project. And he says slip form concrete sounds very, very cool. And it really is very cool. And the footprint, lots of smaller footprint, lots of advantages. But we also have Steve Burrows in the house. Looks like he's on his private jet going somewhere today. As the core carries all gravity and lateral loads, it must be larger than otherwise, right? And increasingly so the higher you go. So I guess it's a question: is the core having to get bigger as you go up? And Steve is an engineer, so
we always, it's great to have the structural engineering community. We have lots of structural engineers, obviously, in our group, and then we do peer review and everything else. The short answer to the question is that would be kind of the intuitive thought process, and but when you interrogate the design and look at the materials that go into it, especially concrete being in compression and not in a tension state. Actually, our cores are more efficient and lighter than a conventionally built structure. And so, and again, I don't want to say that as a across the board. It's a generalization in terms of the type of build. But what's unique about the structure is it's really agnostic to use in terms of whether it's going to be a commercial office building or a residential tower or a hospital or lab. And so, it's loading, its size, it's all of those things. But I would say on average, our cores are between, and again, this obviously will be dependent upon geographic region and the seismic activity in any one market or that specific area. But our cores in current designs are between 8 and 12 inch with minimum ACI steel. And so, again, the cores operate with an incredible amount of efficiency because of their state of being in compression as opposed to tension and the reduced weight overall in the structure.
Yeah. So thanks for the question and comment, Steve. All right. So this technique has been around for quite some time. Dan, why are we not seeing more of it? I mean, just 30% on site costs alone is a big number when you're talking about these, $100 million plus jobs. So why do we not see more of it?
I think, our industry as a whole, which I'm sure most, if not all folks that are tuned in kind of understand that, our industry is a pretty risk adverse market, as well as, kind of the development community. And so, if it's new and it hasn't been seen before, it's not going to get the traction I think that it deserves. It's the same kind of thing with even volumetric modular operations. I mean, it's taken 20 plus, if not more, years to really get some traction. And even there, I don't think we're there yet. But there's a lot of advantages to the modular and prefabricated elements, just as an industry a whole on the conventional side, if you were to look at innovation and construction. Right. So, when you put something like top down into play, and it really hasn't been built since we did it in the 70s. You don't get people aren't rushing to it. You get a lot of excitement, you get a lot of interest. But at the same time, I don't think that there's we're building out that supply chain. Our delivery is a vertically integrated flow. We have large subcontracting partners that have created design desks to bring this to market, and a build strategy. But at the same time, that needs to grow. And once we do a few more recent ones, this is going to, I think, catch on like wildfire.
This makes so much sense, especially with the world the way it's turning now, more offsite being looked at, whether it's panelized, modular. And you're right, even that space has not grown the way we would thought it would grow. Yeah. But that's kind of changing right now. So, and it is starting to grow, and we're seeing more companies use those processes. And what I think's really neat about what you're doing, Dan, is you're already kind of building offsite. You'll pretty much have a pop-up manufacturing facility at the base of all the cores of these buildings. And you guys, are you looking to implement more modular technology, bath pods, panelization, and do that right on site and create your own manufacturing, your own builds on the first floor?
Yeah. So, I mean, currently the model of delivery is that we have, I would say 60% of the building is done offsite and is, some sort of prefabricated element. And then we assemble it on this, what I like to call, our deck frame is, equivalent to having a Ford F-150 chassis. Right. And we create a manufactured workplace or flow from a more manufacturing production at grade, right, or at the site. And so it's that integration of how we take industrialized construction and move it more into that manufactured space, and then take what we do on site and try to make the predictability of workflow as succinct as we can. And that's where the lean methodology and all the other just-in-time delivery and our MRP processes come into play. But to have that vertical integration is fundamentally key. The future for us is, yes, we will do more of our own offsite fabrication in terms of an actual brick and mortar facility, but that's on our strategic long-term investment strategy. Currently, we're working with supply chain partners that provide some of that. So we do when the deck is completed and is ready for any topside loading, we want to have as many finished elements slid onto that deck as possible. So whether those are, completed bath units, completed room units, right. Any type of other modular volumetric finished product, to the extent that it's readily available to meet our structural system, which can easily be done, is the goal. And we do that. So, and then obviously loading demise space and any materials that go on it.
Sure. And so let's talk about, the 60% that's offsite. So what is that 60%? Is it panelization? Is it modular? Is it bath pods?
Yeah, so it is. It's in that interior space. It's modular. It's panelized. We have supply chain partners. We work with Falk Built on interior demise space. We work with our MEP contractors that kit out and do modular assemblies for wet and dry mechanical, electrical systems. And then, so anything that we can, do offsite to bring to market in terms of having a more finished unit as it pre-lift is our intended goal. And so we do, have relationships where we work with those, modular bath and other, providers. The long-term goal, though, is to more strategize, to lean even those units out from a structural perspective, because the structure itself is the deck of what we're putting it on.
Right. And I'm still trying to grasp, as a non-engineer, how you cantilever such long spans back to the core of that structure. Now, I know somebody like Steve Burrows probably gets that. For the rest of us out here, it almost doesn't make a lot of sense, how you can bring those spans all the way out.
Well, and that's, the beauty of the system is to create value, right? And is to create, a more, compelling structure and a better built structure. And I think, obviously floor utilization is one of our drivers. The constraints to building this system, so how it won't work, is if core locations relative to their relationship to one another, if it's a multi-core structure, don't work out. Specifically design those cantilevers. And then obviously the cantilever requirement, right? So what is your FAR, and how are you doing your edge of core to edge of deck for that distance?
Floor area ratio, yep.
Mm-hmm. Right. And so what we really are looking at doing, and so far we haven't come up with a structure that really can't be built, that is compared to a conventional design, and we've been able to meet it in some instances. The structure, because of its versatility on foundations, has really been a driver of more value. Because if, say, there's an easement underneath the property that required, no loading, so you couldn't site a building for a specific footprint. Well, because our cores only require foundations a certain depth, or a certain element under the core, we can rotate the building or move it around to miss those subgrade easements or restrictions. So a lot of flexibility. But from a cantilever perspective, going back to the original question, it's really, it depends on the use type. Commercial and residential are a little bit different for live and dead load analysis, but pretty much it's feasible for most all building types.
So areas that you typically find yourself doing this type of build, I mean, I guess it could be anywhere. High density areas is a solution for this, because you're not having to bring big pieces in. You're doing it locally.
Yeah, well, our target has always been working in the growing markets, right? So where are the markets that are, adaptive to innovative construction technology and methodology, but also have, a very aggressive building program in terms of what's happening. I mean, the Austin market, Seattle, Denver, it can be, basically anything you want to build over 10 levels is where the price, at price and time value prop really kicks into play. But from a geographic perspective, we work pretty much nationwide. Slight exception within the New York market.
All right. So I'm an engineer. I'm an architect. I got a big client, multi-millions of dollar project. How do I work with you guys with a building that I've already designed, or I'm thinking of building, and convert it into this type of construction, so I can have heads on beds or people at desks a year sooner than the traditional construction? And are you going to guarantee me that 30% savings?
Well, we have a procurement model that we always put in front of our owners that shows them what the strategy looks like to build. But we have a vertically integrated supply chain as far as from a design and a build perspective. But to answer your question, the earlier we can get into, whether you're a design firm or even a building group that is working with developers that looks at this space, how can we talk to them about reprogramming their ROI, their pro forma, right? Because that's what it's about. It's about creating value for all stakeholders. A lot of developers only ever see one version of a tall building structure, because that's all they've ever been exposed to. So, if we can show them the alternative, they can run a different, investment strategy on it and look at cost of money, increase utilization, sustainability metrics, obviously time to delivery, and your pricing elements, and so, and all of those things play into the value prop. And so this is one of the things that we're aggressively doing, is going out to the market to try to help educate people of what's available, and to talk about the process and the workflows, and the building technology of the future, because it is a more efficient process.
Sure. I mean, it makes sense. And you sent me a solutions benefit chart, and we'll show that here coming near the end of the show, that talks about all the features and benefits that you get from this construction. But it just makes sense to me that more people using this, especially on the large projects. When you get into, if you're even in $1 million, let alone hundreds of millions of dollars, this is big time savings and big money savings. So getting it out there to me, just, I mean, it
Oh,
makes a ton of
absolutely.
sense. And using,
Yeah, and that's really what we've spent the last literally 5 years, not just and we're growing that from an internal strategy about how do we
right.
get on the industry to get more awareness of it, but also the development community and the real estate space. If they're going to put up a building, they just need to know what the options are. And historically and traditionally, they're only ever provided one structural solution, or maybe a secondary solution in modular, right? And not knocking modular. I think modular is great. We're all for innovation, and but again, even stacking, quote unquote, stacking boxes has significant limitations. And so, our system, whether we compare it to the conventional, cast in place or steel structural build, or a modular type operation, in terms of just that stacking of boxes, is an incredibly efficient, compelling story. But we do integrate a lot of those modular components and see that as a path forward to co-develop new opportunities, for sure.
Yeah. Listen, I mean, I don't have to be an engineer to already understand that there's a lot of efficiencies that can come out of panelization, modular bat pods for what you're already doing and using the same platform to lift it up. So I can definitely see the future for what you guys are doing, heading more in that direction, more than what you're already using. So why don't we say hello to a couple other people out in the audience and take some more comments, if that's good. Oh, no. Henry Mickelberg out of LinkedIn. Naughty. He got slapped on the hand by LinkedIn. They put him in timeout. That's what happens when you question everything. And but he's one of the smartest guys in this offsite space. So, all right, good to see some proper civil engineering on the show. What are your thoughts in regarding top down and bottom up at the same time, using Lang O'Rourke's One Hyde Park London project as an example? Are you familiar with that project?
I need to go and take a look at it, and know a lot of different projects around the world, but haven't really been dialed into that one.
Send us a link, Henry. Maybe we can pull it up and take a look at it before the show ends here. And welcome back, man. You made my day. It's so good to see you. I'm glad we got whatever they did. They messed up somehow and knocked you off. Oh, there you go. Welcome back, Henry. I feel like we need to have balloons pop up on the screen like it's his birthday. He's born again now, Henry. Perfect. All right, Steve Burrows. I knew he's going to be all over this one. Steve Burrows is one of these guys I call like one of the most interesting men in the world. He should be on a Dos Equis commercial. How are the horizontal joints between floors made weather tight?
When you're the exterior skin, or for the exterior skin, it is they're unitized wall connections, and the wall, whether it's, and again, from our design, anything that we can build conventionally from an exterior expression, a glazing, curtain wall, can be done with the top-down system. And this includes, the addition of balconies and other, elements that are proud of the structure or architectural gingerbread. But basically what it is it's a bolt connection, or it's a structural connection to the edge of deck that's obviously in its most cantilevered position. And then the wall assemblies are interconnected to one another. And so there's basically a connection bracket, kind of this male-female, chicken head connection bracket at the top of the wall assembly that runs obviously horizontal, and is connected to the track below it, so that when the building does lock into place, that connected it's a watertight connection, and it's it's a one complete exterior skin, which is in profile. And so what's unique about the system, though, from a structural perspective, is that there's no vertical loading coming down from the floors. We do put serviceability posts at the edge of the deck, which are pretty much incorporated into the exterior skin, which takes into account some minor deflection between its relationship between the floor. But those serviceability posts don't go all the way down to grade. And so what ends up happening is it acts like a large monkey bar. in that perspective. And this is getting into a little bit more structural theory, but it keeps that entire building in compression and shear on the core, so that there's no lateral or no horizontal load going all the way to grade, and that's what keeps the building in compression.
So Steve says, I think the cantilevers are only at the top, and the floors all hang off that. Fire resistance and progressing collapse risks are key. Is that accurate?
No, the cantilevers are in every deck. Each deck is independent of the other.
Got it.
And they don't hang off each other. They're not in. There's no relationship between one plate and the next plate.
All right. Awesome. Hey, there's your balloons, Mr. Henry Mickelberg. There's your balloons. All right, listen, everybody. Thank you for tuning in today. We are live with Dan Esparza, TGE Top Down. We are building mid to high-rise buildings from the top floor down. Yes, you heard me correctly. So if you're just joining, please follow us on LinkedIn, YouTube, Facebook, and Twitch. And if you're not following Dan, you're wrong. If you're not following TGE, you're wrong. If you're an investor, you're in the commercial business of hotels, multi-story buildings, 10 stories or higher, you should be talking to TGE about 30% savings just on the site work. I mean, we haven't even gotten into the buildings and to the almost a year worth of time that you save. So my head's going all over the place. So, and also we always want to,
oh, I'm sorry, go ahead.
We always want to thank our sponsors for everything they do, Forward Solutions Group and Howick. We appreciate both of you very, very much. So thank you to both of them for all your support. All right. Let me pull up this other cost savings chart. I told you, man, time goes fast. It's already 45 minutes into this.
Yeah.
So
I know, time flies when you're having fun.
I know, you got it. Don't get disappointed. It's just the way it works, you know. Let me see if I can find that picture.
Yeah, just a little bit of background also. I think I mentioned my partners, but the historical kind of genesis of this process resides with Charlie Thornton, and he's the T in TGE. It's Thornton, Grillo, and Esparza. But Charlie is the founding principal of Thornton Tomasetti, which is, obviously one of the largest structural engineering firms in the world. And so, Charlie is probably a market leader in tall building construction and tall building design. Some of the buildings to his credit are, Kuala Lumpur Towers, Taipei 101. Some major, some of the largest structures of their day are Thornton designs. And so, Charlie and Jeff and I have been, rolling out this new strategy and bringing this new delivery process to market. Again, it is the foundation of the building is a structural system, but it's culminating the nexus between construction and technology. And how and manufacturing to a great degree, and how those actually interplay in a compelling way, and I think in a substantive way, to tall building construction, where we haven't really made any major strides in innovation to delivery of the structure. How from a materiality perspective, how do we reduce the critical weight of the building? How do we take out material by mass? And so those are things that we've solved. And we're bringing to market, and then it's coupled with actually a delivery methodology to have core and shell lifting mechanisms and putting those in compression and shear on the core are all integrated into a delivery method.
With the system, how many builds do you guys have now throughout the world?
Well, there's 7 built here in the U.S., 2 internationally. As I mentioned earlier in the show, and the cast, the ones here in the U.S. have gone through significant, performance, historical performance evaluation, and it's a 50-year strategy that's been in play. Most of those are in the Bay Area, as I mentioned, and then 2 on the East Coast, and then we have 2 international structures for about 1.2 million gross square feet with a blue chip client.
With a blue chip client. And what do you guys have coming up now?
It's really interesting. And I think a lot of people in the innovation construct tech space will see that, kind of post-COVID, it has really moved the needle. And things are becoming a lot more aggressive in terms of how we can do things differently in the space. in terms of construction and construction technology, and where that risk tolerance is shifting. We have we have about 15 buildings in play right now. We've got 3 in pre-construction, probably break ground by Q4 of this year in Denver. Just in terms of where we're at for the permitting processes, that could be extended based upon some other external or permitting issues, but all things moving forward. It's a very robust backlog, and it's exciting. And as I mentioned, that with the post-COVID switch, people are actually starting to say, hey, we need to do things differently. Projects don't pencil. Year-over-year cost of construction and time, time and cost to build is, increasing annually. And so it's not getting better. It's getting worse. And so, especially when you're building in a tall space. So we're, obviously have a counter to that, and are excited to bring it to market.
I'm sure you are. So I had a hard time opening up that document, so I made it an overlay. So we're going to get covered up a little bit, but everybody should still be able to hear us just fine as we walk through this. So, right. So we're looking at our cost savings, total reduced 15%, floor space, leasable floor space increased by 10%, and views improved, enhanced safety, as we discussed, accelerated schedule, 25 to 40%, excellent sustainability, 50% reduction in embodied carbon, and material structure or weight reduced by 50%. Tell me this isn't true. How could you have all of those gains and all those efficiencies and not everybody out there calling you to build their building?
Yeah, no, and everybody always says you've got 3 benefits, but you can only have 2, right? One's got to be sacrificed. And so you're sitting here telling me I can check all the boxes. How is this not, not like the golden egg? And the response to that, quite frankly, is that, it's a proven technology. The legacy and the history is behind it. The performance in our last 1.2 million gross square feet of build is actually better than these numbers that you see on the screen. This is actually a more conservative approach of where we think the domestic U.S. market is in terms of turnaround, just because of where we say again, the last building that we talked about was, in a developing market and international. We see the productivity of workflow being a lot better here in the U.S. as well as the supply chain logistics. And so as we've managed to continue to lean those things out, put the team together and develop strategy, these numbers are I think on the more conservative side, but definitely ones that have been proven in the past and will maintain better numbers in the future. So again, it's about creating value. You want to be a consistent supply chain partner, but you want to create value not just to the owner, but to the project, but to all stakeholders involved. And that's really the key culturally for us. That's the driver, and always pushing innovation. Right? It's a process where we're never going to stop trying to innovate on the structure.
Well, we shouldn't stop trying to innovate ever, right? I mean, this already is ahead of its time. And, we're in the position we're in this country with housing affordability, lack of housing, unaffordable housing, because we've always been doing it the same way. But, and we haven't been innovating. And this is a system that I think was way before its time until today. Now, I think it's super relative, and I think people can start grasping, really what it's all about. Yeah,
and we're excited about that. Obviously, it's we're also, part of the reason that we definitely wanted to be engaged with what you do is your network. We want to bring it to not just from an owner perspective about how we can create value there, but how we can increase and educate a supply chain, and show a new way of building, and have them be participating in part of that innovation strategy. We don't do it alone. And so I think, the key to all of these things when we talk about, building something different and doing something different is including people to be successful. And we are, obviously we are all about that. You can kind of go to our website, see some of our team partners. We're in the middle of updating that, but it's the current site's down there now. We also have Verse Buildings Group. That's, Verse Buildings with an S.com. Very proud of, the lineage of what we're developing, but so it's important for us to get, some exposure to not just supply chain, design professionals, owners, and the market in general.
Yeah, for sure. All right, a couple more questions. We're about out of time here, so let's say hi to a few people. Damian Stapleton is joining us. Sorry, looking forward to watching this on YouTube. Speaking of YouTube, you best all go there and subscribe right after this show, because our YouTube channel is growing mighty, mighty fast. We are pushing 1,600 hours every 28 days. That's 24 hours a day that our content is now being consumed, plus more than 24 hours a day. I don't even know how to do the math, Dan. I need smart guys like you to help me figure out the math. Damian Stapleton says, I recall the central bank in Dublin, Ireland's Dame Street used a similar system. I think that it was there in the 70s. Here is a link. And so he put a link to it there. You familiar with that one?
There's a similar system that was engaged in that.
Perfect. So, I mean, it's out there. We just need more people to know it. Steve Burrows, last question of today. Is TGE acting as a D&B contractor and quoting GMP below market price?
So the short answer is yes. That's the quick and dirty answer, but it's more nuanced than that. We do work as a systems facilitator to the owner. We also have some, large general contracting partners that we work with. But again, it's to grow the market. This is a technology that we can help other contractors improve on being, a builder in this space for tall structures, and assist them on building out further. So we've operated in a joint venture capacity as a systems facilitator, a CM at risk, and a couple others. But there's a number of different procurement models. But our process, our group, is a vertically integrated supply chain to bring top down to market. So whether that's working in hand with a GC partner in a market that we're not currently in, to bring it to fruition, or working directly with an owner developer. There's a number of different strategies there that we've engaged.
Yeah. All right, Jerry Dunn, thank you for joining us as well. And Jen put up versabuildings.com right here. Is that I think was the project that they were talking about, which uses a similar concept. So, Dan, we ask everybody on this show, what is your one thing? If you're to leave us with anything today, whether it's personal or business related, what would be the one thing that you would tell the youth of today joining this industry, or looking to join this industry, or anybody out there that's not familiar with the type of building that you do at TGE? Let us know. What is your one thing?
Yeah, I do a lot of work with ACE Academy and ACE mentoring, and with kids in construction and building. For me, it's always about, be innovative, believe in yourself and be innovative, but be engaged. And those are the things that, have been done well for what I've in my career, but also to, listen and be engaged. And there's a lot of that. It's a process of continual improvement. There's ups and downs, but that is a huge part of our industry, and an exciting one at the same time. So always like to pass that on to younger folks, especially, for all the work we do in ACE.
Love it. All right,
but
Dan,
one
thank
thing
you
for
so
us
much.
is always, to innovate, to be innovative in our space, and to be a collaborative partner.
That's right. We're moving things forward. We are changing the industry as we know it. We are building it better every single day. And every single day, we're getting more and more people hopping on the Build It Better train with Dave Cooper Live, and now Dan Esparza and TGE Top Down. Dan, thank you so much for joining us today. And one last time, thank you to our sponsors, Forward Solutions Group and Howick, have been sponsors of our Wednesday Product Spotlight show for just about a year, if not longer. So we really do appreciate you. Without you, we cannot bring you all this great content and find people like Dan to share the knowledge of what's going on out in the world. So with that said, everybody, be sure to join us this Friday with Mike Schaefer from Mitsubishi. Is going to be on Building Science Friday, BS Friday. You do not want to miss it. 10 a.m. Pacific, 1 p.m. Eastern. And then next week, big week, we're live on location at Boxable. That's right, Elon Musk bought one of them. There's rumor that he's living in it. I don't believe that, but there's rumor that he's living in it. And if he is, awesome. But we are going to be live on location with this company who is hot on the market right now. At least the media is all over it. We're going to be one of the first ones to show you a live interview of their production facility as we hang out with the founders and CEO. There you go. So, Dan, don't miss that show. That's going to be a fun show.
Absolutely. No, it's on the calendar already.
I love it. I love it. All right, everybody. Dan, you don't go anywhere, and everybody else out there, we will see you this Friday at 10 a.m. Pacific, 1 p.m. Eastern. Until then, have a great day. I'm going out to hang out with Steve Glenn from Plant Prefab right now, so I got to run. I got a meeting. We'll see you.
Thanks,
Bye
everyone.
now.